So we need to determine what is happening in this problem. And what we see when we read the problem is that we are going to have an inequality that represents the cutting. And then we're going to have an inequality that represents the sewing. So we need to look back at the problem and we need to determine, well, how much time are we cutting to make a jacket? Well, each jacket requires 1 hour of cutting. So it's going to be 1x, because x represents the jackets. And how long does it take, or how many hours does it take for us to cut? Tiffany?
Cut pants?
Nope. Yes, to cut pants, yes. 2 hours to cut pants. How much total time do we have available at our company to do the cutting of the jackets and the pants? Tiffany? 20 hours. Less than or equal to. We've got 20 hours, no more. Well, then we switch over here to the sewing. We're going to do the same thing. We go back and we look. How much time is it going to take for us to sew a jacket? And to sew a jacket, up here in our first bullet, it says that it takes 4 hours of sewing. And when we look at our pants requirements, it says that it takes 2 hours of sewing. And once we know that, then how much time are we given for the sewing in this company? That's our third bullet, and it says that we've got 32 hours, less than or equal to. Now lastly here, we need to assume that we are going to make some jackets. And we need to assume that we're going to make some pants. If we don't make any, we're not going to make any money, which is our ultimate goal. How many items need to be made each day to produce the maximum profit? So once we come up with our inequalities, what we need to do is we need to put these into slope-intercept form. So at some point in time, somebody's going to correct me and tell me that on my blue equation, it should say 1x plus 2y. Why? 1x plus 2y. Because now that we have the equation correct, we can put this equation in slope-intercept form. So we're going to subtract x from both sides. And we get 2y is less than or equal to negative x plus 20. It's 2 times y. So we can divide both sides by 2. And we have y is less than or equal to negative x over 2 plus 10. The number in front of the x, which I stopped writing, is 1. But what we know from this is that our slope is negative 1/2. And our y-intercept is 10. And let's go ahead and graph it while we're thinking about this one. So we're going to start with b. b is 10. It's the y-intercept. Our slope is negative 1/2. Down 1 over 2. Down 1 over 2. You have rulers. I know that I am going to draw freehand. But there's our first inequality, our first constraint. recommend that you do use it as straight edge. Once we get the blue constraint graphed, we're going to go to the green. And again, we need to put this into slope-intercept form. So let's subtract 4x from both sides. We get 2. Y is less than or equal to negative 4x. Well, 32. Well, it's 2 times y. The opposite operation is to divide by 2. And we end up with y is less than or equal to negative 2x plus 16. Which means that our slope of our line is negative 2 over 1. Remember, slope is rise over run. Our y-intercept is 16. And let's graph this constraint while it's fresh in our mind. So here's 16. And our slope is down 2 over 1, 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 down 2 over 1. Again, use your rulers. And there's our second constraint. But we can't forget that we have x is greater than or equal to 0, and y is greater than or equal to 0. We need to assume that we're going to make pants or jackets or both. So when we draw our line here for x is greater than 0, we're crossing the x-axis. This is a vertical line, which means that y is greater than or equal to 0. Is a horizontal. And in a moment, we're going to shade, and I'm going to start with the 2 red lines. X is greater than or equal to 0. It was the vertical line. It says greater than or equal to 0. That means that we're looking for where are the values? What side of the line are the values greater than? Zero. To the right or to the left? Where are they going to be greater? Greater than 0. To the right of 0 or to the left of 0? To the right. So, I'm going to try again up here to get the highlighter there, and you don't have to have a highlighter. Not a fancy shader, but it would be really nice to be able to shade. There we go. To the right of that. The horizontal and the vertical lines are the easiest one to see. Where are they greater? So it's still greater for y is greater than or equal to 0. Are we going to be above or below that line? And above is going to be bigger than the 0. What I want to look at again today is the test point in here. And when we go back to the blue line here, I mean, sometimes you can see where to shade intuitively, but you can't always. So the best way is to pick a test point on this graph. And if I can, I'm going to pick 0, 0. I'm picking 0, 0 because it's not on the blue line. It's also not on the green line. I'm going to put it back into the original equation. Does 0 plus 2 times 0, is that less than 20? Can't see it very well. Is 0 plus 2 times 0 less than or equal to 20? And because it is, we're going to shade this blue line on the side that makes the inequality true, which is where this x is. So it's kind of underneath. What is that? Kind of underneath the blue. We're looking for a polygonal region. We're looking for the feasible region. So the next part is, let's do the same thing with the green line. 4 times 0 plus 2 times 0. And the question is that less than or equal to 32? And it is as well. So we're going to shade there. Where on the side of the green line where the x is, which is kind of to the left. And as we take a closer look then at our picture, we're going to see our feasible region. Just here. From there, now that we've got that picture, what we want to do is we want to list the coordinates of the feasible region. It does not matter which order you list them in, but you need to have all of them. I see an order pair here, 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 and here. Again, doesn't matter which order you list them. But what we have, 0, 0. We have over 0, up 10. We have over 8, up 0. And we have over 4, up 8. Just make sure you have all 4. So we've done the hard part now. The next part then is to write a function for the total profit on the clothing. So that's where our f of xy, our quantity equation, comes into play. So we have to go back and look at the original problem, and what we're looking at is how much money are we going to make on a jacket that we sell? So we look back there, we're looking for money on our fourth bullet. If the profit on a jacket is $14, then we're going to get 14x. If the profit on a pair of pants, then, is $8, we'll say what? Determine the number of jackets and pants that are needed to make a maximum profit. So now what we're going to do to finish this problem is we're going to take these 4 ordered pairs that we found as our vertices of our feasible region, and we're going to put them back into this equation, and we're going to look and see what's going to give us the biggest number. So when we start here, we're going to do f of 0, 0. That means we're going to put 0 back into our function for x and 0 back into our function for y. And ultimately, we end up with 0. But we have 3 others here. Remember that our x value are the jackets, so this next inequality, or this next order pair, says that, well, we're going to make 0 jackets, and we're going to make 10 pairs of pants. That's what that order pair is. X is the jackets, Y are the pants. So this time we're going to put 0 back in for X, and 10 back in for y, and we get 0 plus 80, which is 80. Better than 0. Well, the third order pair that I have listed is 8, 0, so this time that means that we have 8 jackets and no pairs of pants. So we're going to put 8 back into our function for x, and we're going to put 0 back into our function for y. And 8 times 4 is 32. 8 times 1 is 8, 9 times 11. 112 plus 0. And then finally on our last ordered pair, and it's coincidence, but we have a combination. We've got 4 jackets and 8 pairs of pants. So we're going to put 4 back into our equation where we see x, and 8 back into our equation where we see y. So it's 14 times 4 plus 8 times 8. So 14 times 4 is 56. 8 times 8 is 64, and when we add those, we get 120. So finally, after all of that work, we can answer the equation. We can answer the question. And what it is how many do we have to make of each? Well, our biggest number over here, between 0, 80, 112, and 120, 120. So that means that we're going to have to make 4 jackets, 8 pairs of pants, and when we do that, we're going to end up with $120 profit. The liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C daily. The cup of dietary drink X provides 60 calories, has 12 units of vitamin A and 10 units of vitamin C. Dietary drink Y provides 60 calories with 6 units of vitamin A and 30 units of vitamin C. Suppose that the dietary drink X costs 12 cents per cup and the dietary drink Y costs 15 cents per cup. Determine which variables you will use to represent dietary drink X and dietary drink Y. And since we were so creative in making this, I know that you'll have trouble understanding, I say sarcastically, that X is going to be drink X and Y is going to be drink Y. And what we need to decide now to write our system of inequalities is, what do we have going on here? Well, if you look at the directions here in Part B, it says, write a system of inequalities to describe the minimum daily requirements of calories and vitamins from these 2 drinks. So our 2 things going on are calories and vitamins. So we need to write a calories inequality. And then we need to write a vitamins inequality. But the thing is, we have vitamin A and I'll try one more time. We have vitamin C. So right away, we're going to be writing 3 inequalities instead of. So you may want to write this out on paper if you're really trying to put everything together. This might be the part here. And it's not so much the inequality here, it's putting the inequality in the slope-intercept form. But if we look at calories here, it says a cup of dietary drink X provides 60 calories. 60x. A cup of dietary drink Y provides also 60 calories. But how many calories do we have to work with? And if you look back up here, we see that we have at least 300. At least means greater than or equal to. We have to have 300. We can have more, but we have to have 300. That's what the at least means. And the at least is really important in this problem. Vitamin A. Then when we go to our next one. Well, if we go back to dietary drink X, there are 12 units. Yes, Camden? No, it's supposed to be greater than, because at least. At most would be less than or equal to. And that's the difference between the page 1 and here. So, for our vitamin A, 12 units of vitamin A in drink X. How many units of vitamin A in drink Y? 6. And again, the at least. At least means we have to have 36. I can have more. Then we get to vitamin C. Vitamin C. Well, I can't see it right now, but there we go. In drink X, how many units of vitamin C do we have? We have 10. How many units of vitamin C do we have in drink Y? We have 30. And again, that at least says that we have to get at least 90 units of vitamin C daily. Now, after we get those 3, what we have to do is we have to keep in mind here that we're assuming that we're going to have some of drink X and some of drink Y. We might have all X to get what we need. We might drink only Y to get what we need, or we might drink a combination of both to get what we need. But in order to find that out, we need to graph. And in order to do that, we're going to have to put this into slope-intercept form. So we've got 60x plus 60. Y is greater than or equal to 300. We need to solve for y. So we're going to subtract 60x, both sides, and we get 60y is greater than or equal to negative 60x plus 300. Divide both sides by 60. And when we do, y is greater than or equal to negative 1x plus 5. And let's graph it. Now that we are working with it, our slope is negative 1 over 1. Our y-intercept is 5. We wanted to start with the 5. So d is 5. Down 1 over 1. 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 There's our first constraint. So we can go then to 12x plus 6y is greater than or equal to 36. We're going to solve for y. Move the 12x to the other side. get 6y is greater than or equal to negative 12x plus 36. And divide everything by 6. We get y is greater than or equal to negative 2x plus 6. Which means m is negative 2 over 1 and b is 6. So when we come over and graph that, and again, if you don't like m for slope, write slope. If you don't like b for y-intercept, write y-intercept. But when we draw our picture here, it's down 2 over 1, down 2 over 1, down 2 over 1. And there's our second inequality. So now we still have the third inequality, the lilac colored inequality. And its inequality is needs to be fixed a little bit because it looks like I forgot to write the y. Hopefully you didn't forget to write the y. But it's 10x plus 30y is greater than or equal to 90. And we want to put this into slope-intercept form, which means that we have to solve for y. So we're going to subtract 10x from both sides. And we get 30y is greater than or equal to negative 10x plus 90. Divide everything by 30. And we end up with y is greater than or equal to negative 1/3 x plus 3. That means, even though I'm still running out of space here, that our slope is negative 1/3, and our y-intercept is 3. We're going to graph. 1, 2, 3. And it's negative 1/3. Down 1 over 3. Down 1 over 3. Down 1 over 3. And then to finish up this graph, we have x is greater than or equal to 0 and y is greater than or equal to 0. We've got our vertical line and we've got our horizontal line. I'm going to try to make it a little bit better. So now that we've got everything graphed, what we need to do is we need to shape. Let's start with the red lines again. X is greater than or equal to 0. Where is the value going to be greater than or equal to 0 compared to our vertical line here? It's going to be here. And greater than or equal to 0 for our horizontal line is going to be above. If we look at our blue line, again, we're picking a value like 0, 0 that's not on the line. If we go back in here, I got space right here, is 60 times 0 plus 60 times 0. Is that greater than or equal to 300? In other words, is 0 greater than or equal to 300? And the answer is no. 0 is not greater than or equal to 300. So where we shade is going to be where that x isn't, which is kind of above that blue line. When we look at the green constraint, do the same thing. I'll try to squeeze it in. It's 12 times 0 plus 6 times 0. The question is that greater than or equal to 36? Well, is 0 greater than or equal to 36? No. So once again, we need to shade where that x is not. which is going to be here. And finally, with our lilac line, we can still pick that value 0, 0. And the question is 10 times 0 plus 30 times 0, will that be greater than or equal to 90? Well, 0 plus 0 is not greater than or equal to 90, so we need to shade where that x is not. So we're going to shade here. And ultimately where our graph has its feasible region is here. So now that we've got that, what happens is that this feasible region is unbounded, but we still do have some coordinates of the feasible region that we can use. We've got a value here, and we have a value here. We have a value here. We have a value here, and we have a value here. And what are those values? Well, looks like 0, 6, 1, 4, 3, 2, 6, 1, and 9, 0. So after we've come up with these values, it says write a function for the total cost of the dietary drink X and Y. So when we come over here to write it, we need to go back and look at the original problem. It says dietary drink X costs 12 cents per cup. So it's going to be 12 cents. And dietary drink Y, it costs 15 cents per cup. So we want to determine how many cups of each drink must be consumed to minimize the cost, but we still meet the daily requirements. So we're going to take our values and we're going to put them back into our function here. So I can't see my order pairs, but the first one is 0, 6. So it's going to be f of 0, 6. So it's going to be 0.12 times 0 plus 0.15 times 6, which gives us 0.9. Our second order pair that we had listed is 1, 4. So this is going to be 0.12 times 1, putting the 1 back in for the x, and putting the 4 back in here for the y. And if we type that in our calculator, we end up with 0.72. And what we're saying here in this green equation is that we would have 1 unit of dietary drink X and 4 units of dietary drink Y. But we still have 3 more to go. 3, 2 is our next order pair. So we're going to take 3 and put it back into our equation for X, and we're going to take 2 and we're going to put it back in here for Y. And we type that into our calculator. And we get 0.66. And then, as we continue here, f of our next order pair with the 6, 1 we get 0.12 times 6 plus 0.15 times 1. And type it in your calculator. And we end up with 0.87. And finally, our last order pair is 90. So it's going to be 0.12 times 9 plus 0.15 times 0. And if we type that into our calculator, we get 1.08. But be careful here when you answer the question. Let's look at what the question is really saying here. What the question is really saying is determine how many cups of each drink must be consumed to minimize the cost, but still meet the standard daily requirements. Well, in our answers over here, we have 0.9, 0.72, 0.66, 0.87, 1.08. What we need, because we're minimizing the cost on this, is the smallest value, which is going to be the value here in red. And what that means, how many cups of each drink must be consumed each day? Well, that means we're going to have to drink 3 cups of drink X and 2 cups of water.